Hello, my name is Timothy Garcia, and in this presentation we're going to explore the world of code smells and how we can clean them up through refactoring. Think of refactoring as a way to boost the health and hygiene of your code base. This topic is practical, easy to understand, and something every software engineer will have to deal with eventually. Let's get into it. What are code smells? Code smells are symptoms of poor code structure. They are characteristics in your code that may indicate a deeper problem in the code base. Code smells are not bugs and will not necessarily cause your program to crash or malfunction. However, they do signal that your code could be cleaner or better organized. They are often signs of design flaws that can make the code harder to maintain, extend, or debug. Code smells can make it especially harder for other developers to work on the same project or to build off an existing project. Recognizing and addressing code smells is a core part of becoming a better software engineer. Let's take a quick look at a few common examples of code smells. Long methods. A long method often tries to do too much and can be hard to test or reuse. Large classes. A large class is usually taking on too many responsibilities, which violates the single responsibility principle. Duplicated code. Duplicated code is a maintenance nightmare. Changes have to be made in multiple different places throughout the code. Feature envy. Feature envy often occurs when one class is overly reliant on another class's data or behavior. Switch statements. Switch statements often indicate that polymorphism might be a better solution. Polymorphism is a core principle of object-oriented programming that allows different classes to respond to the same method call in different ways. For example, instead of using a switch statement to apply discounts based on customer type, you could create separate classes for each customer type, each with its own getDiscount method. Then, you simply call customer.getDiscount without needing to know the specific customer type. This reduces complexity and makes the code easier to extend. These are all signs that refactoring might be needed and that your code kind of smells. Why do code smells even matter? Code smells matter because they introduce technical debt. Technical debt is the hidden costs that come from choosing a quick solution instead of a better one. Over time, these quick solutions and poor structures slow down your ability to add new features or fix bugs in your code. They can make onboarding new developers more difficult and can even confuse you when you revisit your own code months later. Ultimately, code smells reduce productivity and increases the chance for errors in your code. Refactoring to the rescue. Refactoring is a process of improving and restructuring the internal structure of existing code without altering external behavior. It's all about cleaning up and simplifying code. This makes it easier to read, maintain, and scale. Just like you might reorganize your desk for better productivity at work, refactoring brings order and clarity to your code base. And just like tidying up your workspace, you'll feel the benefits of it immediately. You might be asking yourself, what are some common refactoring techniques? Well, don't worry, I got you. I'm here to help. Many modern integrated development environments, or IDEs for short, have existing tools that can be used for refactoring. A couple of these tools include extract method. This tool is used when a method is too long or does too many things. It can be used to break methods into smaller, more focused methods. Rename variable or class. This tool can improve clarity and make code self-documenting. renaming methods or classes so that their purpose or use can be easily understood is a great tactic software developers should use. Move method. This tool can be used when a method is in the wrong place or is located in the wrong section of a class. It can be used to move a method to the class it probably should have been all along. Another common refactoring technique is polymorphism. When you see repeated if-else or switch statements, consider replacing the conditionals with polymorphism in order to simplify the logic and reduce complexity or duplication. On the next slide, I will show you an example of one of these techniques. Here we see an example from a common IDE, IntelliJ IDEA, on how to select code and extract it as a new method. As you can see, you select the code you want to extract, right-click, and a large list of options will pop up. One of these options is Refactor. Under Refactor, there are several tools and techniques that the developer can use to refactor the code. When selecting Extract Method, IntelliJ IDEA will extract the selected code into a new method and replace it with a method call. Many other IDEs have a similar feature. This is an easy way to refactor the code and clean up code smells. Let's pause here. I want you to think about a time when you came across confusing or messy code. Maybe it was something you wrote in a hurry, or it was something that you inherited from somebody else. What made it difficult to read or modify? What would you change about it now that you've learned about code smells and refactoring? Look at the example of smelly code in the screenshot. What would you change? In a couple seconds, I'm going to ask you to pause the video. I want you to take some time and think about what you just learned about refactoring. I want you to jot down a few ideas that you can use to refactor this smelly code, or just reflect on some of the smelly code you have encountered in the past. This kind of reflection helps reinforce what you have learned. Please pause the video now and unpause it when you are finished. Well, what did you come up with? I want to thank you for taking the time to pause and reflect. Now, let's talk about some tools that can help you identify code smells so you don't have to do it manually. Fortunately, we don't have to catch every code smell manually. Modern IDEs like IntelliJ IDEA or Visual Studio Code offer real-time feedback as you are writing your code. You will often see suggestions or warnings right in the editor. For larger projects, tools like SonarQube, PMD, and CheckStyle can scan your entire codebase for patterns that indicate smells or violations of coding standards. These tools save time and help enforce consistency across development teams. Here are a couple examples of what PMD and CheckStyle reports look like for those larger projects. Here's an example using IntelliJ IDEA's inspection feature. This feature automatically highlights potential code smells like redundant declarations or unused variables. In the screenshot, you can see that the variable tax is marked as unused, and the variable DSCT has a to-do comment about a bad variable name. Both are examples of code smells and are things that should be cleaned up. Tools like the Inspect feature in IntelliJ IDEA help you proactively find and fix issues before they grow into the technical debt we discussed earlier. Many other modern IDEs have very similar features. Good code hygiene isn't just about refactor projects. It's about maintaining consistent habits. Here are some best practices to use while you are coding. Keep your methods short and focused on a single responsibility. Try not to make your methods complex or difficult to understand. Use descriptive class, method, and variable names that help make your code self-explanatory. Avoid duplicating logic. This is the heart of the drive principle. Don't repeat yourself. Don't wait for big cleanup sprints. Refactor a little each time you touch the code. These small improvements add up over time. You can think of good code hygiene like keeping a clean desk at the end of the workday. When your desk is organized, it's easier to focus, find what you need, and be productive. The same is true for a clean code base. All right, let's wrap things up. Throughout this presentation, we explored what code smells are. These are subtle signs that your code structure might be problematic. We looked at common examples like long methods, large classes, duplicated code, feature envy, and switch statements. Each of these patterns can slow down development, introduce bugs, and make your code harder to maintain. We also discussed how refactoring helps clean up those smells by improving the internal structure of the code without changing its external behavior. Refactoring techniques such as extract method, rename variable, move method, and replacing conditionals with polymorphism give you practical tools for improving your code. You saw how IntelliJ IDEA, a modern IDE, can help you automatically detect code smells, and how tools like SonarQube, PMD, and CheckStyle help enforce quality standards across your entire code base. Finally, we covered best practices for cleaner code. These include keeping your methods short, naming things clearly, avoiding duplication, and refactoring a little at a time. With these habits and the right tools, you can make your development process smoother and your code more maintainable and enjoyable to work with. Thanks again for your time. I hope you are walking away with useful strategies for writing cleaner, more professional code, and I hope you make another developer happy, even yourself, when they look at your code in the future. These references are a great starting point if you want to learn more. Martin Fowler's book is a classic on this topic, and SonarQube is a free tool you can try out on your own code. For the images and graphics used in this presentation, all screenshots of IntelliJ IDEA were created by me and are used under fair use for educational purposes. Other images were sourced from Google Image Search and were included solely to support learning in a non-commercial context. Where possible, I selected images labeled for reuse or covered under Creative Commons licensing and credited the original sources when available. Thanks for watching.